Hello, my name is Lee Presser. This is my show. I speak frequently to very interesting people. Some of these conversations are so exciting, so intellectually stimulating, I thought others might like to listen in. This is the reason we started recording Conversation with Lee Presser.
Welcome to Conversation with Lee Presser. 3D printing refers to a variety of processes in which successive layers of material are laid down under computer control to create a three-dimensional object. This is done by a device which is a type of industrial robot. The process is sometimes called additive manufacturing. To discuss this amazing new industrial process is Chico Weber, the CEO of Squarefruit Labs. Mr. Weber is an engineer and entrepreneur who not long ago graduated from SIUE with a bachelor's degree in manufacturing engineering. He's already created several businesses. Squarefruit Labs has become one of the fastest growing 3D printing companies in St. Louis. Mr. Weber's mission is to create customizable technology which will put into people's hands the ability to create and deliver new products in ways they've never been created or delivered before. He believes society is on the cusp of a manufacturing revolution. Chico Weber, welcome to Conversation.
Thanks for having me.
Just so that people know, last week you and I had a long conversation over at your business, and I was blown away by some of the things that we were talking about. Among these things that I was blown away by was this manufacturing revolution, which you were talking about to me, in which you were saying that the wave of the future was not going to be mass production, but is actually going to be customizable production. Is that, am I got that correct?
Yeah,
explain that to people so that they know what you're talking about.
Yeah, the cultural shift that I think society is really experiencing right now is the shift from mass manufacturing to mass customization, where the uniqueness in all of the parts, all of the components, all of the products that consumers are used to be buying in bulk or buying consistently with previous things. Now they can buy them as custom, unique items that are just tailored for themselves.
Are you still going to be able to sell products as inexpensively as mass-produced ones?
We're moving into that direction. Sometimes it is actually now cheaper for certain components, especially with the integration of 3D printing, to make them a lot cheaper than had it taken for somebody to go down the traditional manufacturing route for the exact same part.
Of course, this is great for entrepreneurs who are just trying to create a product for sale, that'll wind up on TV,
Yeah.
but it is good for them because that way they don't have to, buy by the thousands every time they get an order. If somebody gets an order, then they just crank it out, right?
Yeah. Oh, yeah. For a lot of what we're doing is we take a lot of custom orders. People want unique things manufactured, or they need just a really low batch run of a certain part. Maybe it's a unique design. Maybe it's even just everyday toys for like family members. But that's things that we can now all produce using the exact same machine. But then when you take that down to like a consumer level, consumers don't necessarily need to use this for like a business product like we are. It's just about making like that transition from having to buy things versus now you can actually have the option of printing them at home.
Well, the first time that I became aware of 3D printing was actually at St. Louis Community College Merrimack campus, where they had some 3D printers in this one lab. And it was like, wow, this is cute. And then they printed me out a whistle.
Yeah.
And and it actually had the little ball in there, and it actually worked. And it was like, wow, this is like Star Trek stuff right here. And but I didn't really think that much about it, other than this is great, because I saw they came up with a whole bunch of toys. But you're not talking about just toys anymore. You were telling me that among these customizable items that you were talking about were not plastic, but metal surgical tools. Talk about that.
Well, part of the hugest industry that's taking advantage, I think, there's two of them, but one of them is in bioengineering and biotechnology, and being able to actually create custom surgical equipment, being able to now print in all of the sterilizable like metals, like stainless steel, and being able to do that on a massive scale where doctors and engineers can now collaborate together and actually custom make new tools, more efficient tools, and actually use those tools directly in practice.
You said metal. So
metal.
Right, because those of us who have had any experience with 3D printing, it's like some sort of a plastic material.
Right.
But
yeah.
so this is real metal we're talking about. So you're talking about creating like a scalpel or something out of a printer.
Yeah, there have been, exactly. Using a machine that actually uses some of them use lasers, some of them use like a resin deposition technology that's now readily available. They can actually cure and fuse together metal particles, very similar to what we're like used to with like a MakerBot that uses plastic filament, only using powder, and actually does that in a similar way with layers with higher resolution and making surgical grade components made out of stainless steel.
And you've actually done this?
We've used machines in the past that have. Yeah, we don't currently own any that do that, but some of our business partners, around like the Midwest are capable of doing that. And if we ever need like orders from them, that's how we outsource to them.
Okay. Now we're going to step back a couple of steps here. One, 3D printing technology, while I just became aware of it maybe in like 2012, is actually started, I guess the original designs go all the way back into the late 70s, early 80s. Is that correct?
Yep.
Talk a little bit about the history and why all of a sudden here in the 21st century this has become so much more popular than it was almost a generation ago.
Well, I think that the original belief about, and if you read up the history of of the original patent that was filed, there were several of them. But the first one, the description was very vague for a machine that could draw in layers and how it was actually drawing plastic using dots, and being able to actually form freeform shapes using that. But it was a very primitive technique. But it's a technique that's carried on, and I think the technology was really ahead of its time, especially like in the early 80s for it. Something where a lot of early companies like 3D Systems, Stratasys really took advantage of, and now we bring it back to the 21st century with this technology, and you've got hundreds, if not thousands, of these companies that are all offering their own unique printing experience using their own technology to do it.
Well, one of the advantages to you and guys like you is that those original patents expired, didn't they?
They did. There's newer ones that are constantly expiring, but yeah, a lot of the original ones for using specific like heating elements, using specific lasers, the right type of temperature controls, the build environments, stuff that for us that are working with these printers, that we've messed with them for years, stuff that we really wanted to be able to develop on further, but these larger industries, the companies that were in these industries had a lot of control over, but now those patents are expired, and you're going to see a huge explosion in newer technology with these printers and more advanced components coming out of them.
I was surprised to read how many young people, younger than you even, who are involved in 3D printing, and it's become quite a cottage industry. It almost seems like back in the days when Dell was first building his computers and Jobs was building the original Apple computers. This seems like the ground floor of something that's going to turn into an enormous industry.
Yeah, it's already a huge disruptive industry, and by disruptive I mean that it's an alternative to what a lot of people are used to, but it's an alternative that consumers are really liking. I personally, before I got into it as like a business, I was really interested in just 3D printing for our engineering products, 3D printing for various consumables. I even printed off components for my own car before we sold that off to somebody else. But we when that industry was just booming, and now that you're seeing how there's so many different people interacting with it, there's so many different people that want to print off more and more components, rather than saying, hey, I need to go buy this piece, I need to buy this this product, I can now just custom make it for myself. That's the disruption that's happening there, and I don't think it's going to be something that settles anytime soon.
I saw that in China that they had actually they worked out the technology to build housing units with 3D printing, and this one place, it was like some mansion or something that they built as a test, but it was an enormous building that they were using like old, and I have no clue what I'm talking about here in terms of the product that they were using, but it sounded like they were using all junk construction stuff that had somehow been shredded up. And is that how it works?
Yeah. What they're using just raw material and mixing that in with various like concretes, and they were actually using a deposition type. It's very similar to just the tabletop 3D printers that everyone's used to. They have a much larger one. And this particular company in China is able to produce, I think now it's more, but last I heard it was about 10 a day, just being able to 3D print standard homes.
Well, just so people don't get the wrong, they're not actually building or creating a home. They actually build components that are then assembled together into a house, right?
Yes, but it's very house-like. It's close enough that they put the windows in, they put the insulation in, they put the rooftops, the doors, everything else that you'd expect from a small home.
Oh no, I'm saying they're not actually fully formed buildings.
They just print off the scaffolding for it.
They put together the parts and then it's put together kind of like a mobile home.
Yeah.
Yeah, which I was like, wow, that's pretty. So that is disruptive also, or it's a new way of creating places for people to live. And I imagine a place like China, where there are so many people who still live in rural areas, that this is going to be very helpful to put people into more modern living spaces.
Mm-hmm. Yeah, right now you're actually seeing I think the first transition into probably one of the most commercial applications is for a ventilation system for an airline company. I can't remember if it's Airbus or if it's going to be Boeing who got the patent for it, but there's going to be new ventilation equipment that's 3D printed. It comes right out of a printer. They're putting it directly into the planes. You're already seeing it for some of the latch and some of the exterior components as well, but that's going to be one of the major things that is going to start, push that revolution along for, the next transition is going to be for automobiles, where you will see just directly printed components already in your car. They've already 3D printed full vehicles now as well, but the transition is happening, and more, everyday items are going to be replaced just with 3D printing, just because it's more affordable and it's getting closer and closer to being a better product to do so.
Well, as this industry develops, do you foresee political fights that'll be necessary in order to allow 3D printing to continue to grow? Or you just mentioned printing out cars. I can see there are huge political forces that are involved in the existence of the industry as it is today that want things to stay the way they are today.
Yeah, I think that the disruption that is 3D printing, when you pair it up against monopolies, larger corporations that have maintained their own, their profits with the products that they are making, 3D printing now offers that alternative. And I think because of how rapidly it's growing, how open source it is, how available that technology is for everyday consumers, that you're going to see either them conforming to using similar technology or them forced to change their own regulations so that they can meet the demands of the newer consumer that no longer needs to rely on traditional cars or traditional components and things that they don't have to buy anymore. They now have an option, and I think a lot of companies need to start realizing that, and some have. But the transition is slower for corporations than it is for a lot of us smaller companies that are just starting out.
So it sounds like you're saying that if somebody has a minor fender bender, that they take their car to a shop, and at that shop, instead of having to call up the dealership and say, hey, send me over a new fender to replace this one, they literally could just print out to some specification that's in the printer that fender.
In the future, not today, but in the future, I'd like to see that as a real possibility, and it's something that I know that the automotive industry is very adamant on getting their hands on, is being able to get to that level where you can just print off that component. Mm-hmm. And again, that stretches off into the medical field as well. I know hospitals are in the transition to build that archive, a digital archive, of being able to have components all digital, all rendered on a computer, And whenever they have a piece of equipment that breaks down, any type of system that they need a replacement part for, even just a simple plastic gear, they no longer have to call the original manufacturer to have that part replaced. They can print it directly on site and install it themselves. And something that you'll see with every industry, but automotive is going to be a big one, and the medical industry will be as well.
Going into the medical industry, in our conversation last week, you had said that not only are plastics involved, not only are metals involved, but you're also saying that there is now biomaterial that can be printed. You said the most remarkable thing to me, which I've said to people since then, is that you're predicting that within a decade, you'll be able to print out a functioning liver?
Yeah, so this wasn't my prediction. I think this prediction's still pretty accurate, but Organovo is a huge company. They're based out in California. They do organ printing currently. They have a lot of government funds to do so, but probably one of the first things they'll come out with is a functional liver.
Now, how does this... See, this is... We're now way off.
Yeah.
Star Trek, Dr. Crusher, and all of a sudden you're healed. Let's just talk about reality here for a minute. How do you take a machine and create a functioning human organ?
So I want to say that there are about 20 layers in for a functioning liver. And what I mean is they've been able to successfully print about 20 layers of living liver tissue that...
This has happened already?
This is already happening.
Okay.
This is past publications of what they were capable of doing. They've already worked on heart tissue as well. They can already get blood vessels put together that do function with blood flowing through, and it's kind of interesting to see a petri dish pulse. But one of the fastest things you'll see is cartilage. It's already happening. You don't even need a 3D printer to do it, but to be able to grow and build the scaffolding using a printer, and then actually douse that scaffolding with the right types of cells, you can actually grow various prosthetics, various components that can just be completely transplanted into the human body as replacements. And
for people who have been involved in a fire, a new nose, new ears.
Yeah, and it's already happened. One of the first things that was 3D printing that was replaced in children actually is new esophagus. So they can print those off in about 10 minutes and actually have that replaced directly during the surgery, and they're still functioning.
You also mentioned that there's a capability now that doctors are using if they have a complex surgery, that they can do like a CAT scan of an organ, and then you print the organ itself so that then they can practice on this thing before they actually go inside the person. Did we talk about this, or am I just imagining that?
No, you're not imagining this. Printing off like a model, not an actual organ, but actually printing off like the model of it. Being able to have that 3D rendering available, being able to print off certain fractures for like the skull if you needed, bone fractures, even just for modeling out for newer procedures, so that a surgeon can actually hold that part in their hand. They can actually see it more than just on a two-dimensional screen, but to have that 3D feel for it right before they go into surgery, and while they're actually performing the surgery. So it makes it more precise and actually makes the procedure a little bit more reliable each time.
Yeah, in your office you had a skull that a cutaway of a skull that you showed me. What was that?
Yeah, it was a skull. It came from one of the patients from BJC, I want to say, that they had one of the doctors actually had various CAT scans, and they brought this one over, and they wanted to have something printed off, and the resolution is there, but you can really actually pick out all the fine details that you would need before you even perform surgery, or if you need the uniqueness in a bone structure for one particular type of person. If you're the one being scanned, it is your skull. It's your own part. So it's that level of detail that 3D printing is able to offer with that customization for it.
Well, let's get just a little bit more technical.
Yeah.
and that is, how does this actually work? This is not magic. There's a lot of math involved in this. Not that you're working with a calculator or anything, but it's all math, isn't it? You're creating a program.
Right.
Talk about that.
So in terms of what the computer is figuring out in order to make a 3D print, instead of using a lot of what's proprietary technology, if you're going down the open source route, what a lot of consumers will experience with 3D printing is they have models. They have these computer models that are 3D, various, we call them CAD, computer-aided designed softwares out there that will make these models. A lot of engineers are using it, but now you're just getting everyday consumers that are able to use very simple software to make their own components. Those components are then exported into a certain file type that what we call a slicing engine, which actually takes that part and will actually slice it layer by layer into a lot of hundreds of layers, if not thousands of them, depending on the part. And then that computer will actually read it into a machining language that we call G-code. And that G-code is what 3D printers are reading. And that G-code it's constantly being updated, but it's one of the oldest machining languages. There's different kinds, and we may soon see a transition from G-code to newer languages, newer text. It's a text file, but there's newer different data formats for it. For handling newer parts, but that's traditionally what the printers are reading, and it says exactly the temperatures to print for the right type of plastic, how fast to move, what types of surfaces are we printing on here, the build time, stuff like that for a component, but it's stuff that an engineer would want to see traditionally, and now consumers are playing around with these things, and they can actually get these parts made just like we've been doing out in the factory.
Mm-hmm. Is this something called STL?
Yeah.
I read about.
Yeah, stereolithography. It's the original file format that was actually used, and it was either 3D Systems and Stratasys have been fighting over whoever came up with the the original patents for it, but that is the original file format, and that's something that if you go to websites like Thingiverse, stuff where you can download full files already available, you don't even have to play with the type of software to make them. You can download it, and that's a file format that everybody's most popular one people are using.
Mm-hmm. And but you're saying that that most likely there's going to be some updates of language because you're going to reach logical ends to the capability of the current language?
Yeah, it has a lot of. I would say it still has a lot of limitations in it, but we've been doing pretty good. For a language that hasn't been changing for the last 30, 40 years with it, it's been doing pretty good. Even predates 3D printers itself. It was just recently adopted to be used for them. So I do think there's a lot of room for improvement with it, and with the newer systems, as newer companies are coming out, there's going to be a lot of changes with that language itself. But it's something that printers will probably keep free. We'll keep it open source, and it's something, it's going to be a new traditional route with it. It's that improvement.
Now you can take an object or not you necessarily, but they can scan it with a laser, and that then gets translated into this code or a code. Is that right also?
Yeah, so it gets translated into the stereolithography file format. So you can actually do that. We've got a few scanners ourselves that we use to do that type of work if we need it, but sometimes it's just a lot easier to scan in a part with the right colors, with the right shape around it, rather than actually trying to build that from scratch in a computer using primitives. So with that type of tech, you can scan in people, and you can have I could have you completely printed off and available in several different plastics or metals even, and print that out. And a lot of stores are actually taking advantage of that, and they're offering printed figurines, custom things that have the full depths of color, something a lot more than what you would get out of a MakerBot or even a lot of the original printing systems.
Well, here in the last 4 minutes, I was just also thinking that customizable shoes.
Yeah.
That they could actually do a scan, a 3D scan of your foot, and then print a shoe that is meant for you and you alone.
Yeah, Nike is on that. So
Oh, they're already doing
they're
it.
working
There we
on
go.
it. I don't know if they've
There's no money to be made here.
I don't know if they made it as a full commercially blown thing or if they're just trialing it out. But they have started printing off, at least for like soccer players, just like custom shoes that are partially 3D printed, partially traditional manufacturing with it, and like trying to overlay both materials. But it's down the route, and we're going to start looking at clothing and shoes and all types of apparel.
Well, I was thinking of the podiatrist. When you have a foot problem, they give you those
Dr. Scholl's kind of thing. Yeah.
Right, the inserts. But now, and of course those are pre-made, but now you're talking about actually a podiatrist being able to create a custom, whatever it's called, to put into your shoe, or to create the whole shoe so that you put your foot right straight into a shoe.
Mm-hmm.
Yeah?
Yeah, that's going to happen.
Yeah. So here in the last 3 minutes, what else haven't I asked you that people need to know as basics of 3D printing?
Well, for us and what we're doing, we're trying to push the limit with the industries we can work with. We've got major projects in agriculture, even developing newer techniques to grow plants without soil, and using once we release the data, we'll make that public. But we're working in fashion, so we're talking about the shoes. We've got a fashion show that's coming up in 2016 with 3D printed clothing for models. We're working with renewable energy, being able to even print off some of the components for renewable energy generators, wind turbines, solar cells, even using conductive ink for printing for that. And this is all research that we're currently doing so that we can have it available. Some of it's going to be available in several months, some will be by next year. But it's fast-paced, and again, working with the medical fields, working with Barnes-Jewish, working with the WashU Medical School, and actually providing medical-grade technology using printing, and working with various other industries. Those are kind of the heavy hitters that are going to be investing a lot, and it's a lot of what we're getting for ours. So anybody with 3D printing interacting with that, they're going to see that type of industry exploding.
You said energy area.
Mm-hmm.
Is it possible that doing the work that you're doing, that a home can actually be, quote, off the grid, unquote?
Yes.
At any reasonable point in the near future, and actually be able to run the refrigerator, the air conditioning, the heat, and all the other components that are in a house? Yes.
So the short answer is yes. The long answer is that you have to learn quite a bit on how to do all the installation yourself, and do that without the overhead of having someone else come in there and install it. But for now, yeah, you really can actually do it, and it's another do-it-yourself kind of thing, just like learning how to 3D print.
But homes of the future could just have that built right in, right?
Yeah, because
houses that you're
houses that we're 3D
out.
printing will have this equipment already pre-installed for it. So yeah.
This is pretty fascinating. Well, we'll have to have you come back at some point, not like tomorrow or anything, but in the future, just to give us some updates on all this new Star Trek stuff that you're doing. It's pretty incredible.
I look forward to it.
Thanks, Sarah, very much for being with us today.
Well, thank you.
Appreciate it. And to my audience, I've been speaking with Chico Weber. He's an engineer in 3D printing. He's the CEO of a company called Squarefruit Labs.
Mm-hmm.
And we're going to be putting this up on YouTube. So make sure in the future that you look this up and go show it to your friends. Thank you. See you next time.